Welcome to Imagine It down here at Imagination Station, joined once again by Chief Scientist Carl Nelson. Carl, I know what we're doing today, but it's awesome, so I'm really excited.
It is. It's called the thermite reaction, all right? It's a reaction that happens between iron oxide, like on this rusty sphere, and aluminum oxide on this aluminum foil. So Dan, I prepared like a microscale version. Go ahead and pick up those two spheres there.
It always seems so basic when you talk about it. It's like, yeah, it's just iron and aluminum coming together. You're like, why doesn't it have such a reaction when you just, put the metals together? Normally, but the oxide...
Great question. You need to either, in this case, create a tremendous amount of pressure, one, to break through that aluminum oxide layer to release the really reactive aluminum, or in the case of a chemical reaction, you can add some activation energy, which we're going to do in a second. But with these, go ahead and just smash them together.
Let's get physical. Yeah.
So you're seeing those sparks being generated by the thermite reaction.
It's like he's done this before.
A little bit of practice, you can make some really good sparks, right? So, yeah,
that was a good one.
You got it. Okay, so this is the microscale version. So let's put these down here. Now we're going to step it up and use an actual mixture, just like you were describing. Right over here, I've got some aluminum and iron oxide in this container. We're going to add it. Hold this for me for a second. This is our activation energy. I'm going to add this mixture into these double clay pots. Okay, below it I have a tray of dry sand. Once we initiate this reaction with this giant sparkler, it could reach temperatures over 2,000 degrees C.
That's nuts.
Right? So iron melts around 1,500. So we are going to form molten iron. So that being said, reaction's a little bit unpredictable. Once you put that into the clay pot, you and I are going to step back and admire what happens.
I think the last time we did it, the pot cracked. So I remember that part and go, okay. Normally I just run on principle with these kinds of experiments. This time, probably saved me here.
Okay, so what we're going to do is I'm going to light this up. That's a giant sparkler. You're going to just place it right into the pot, and then we're just going to step away. Okay, you ready? Here we go. Go ahead and place it in there. Yep, step over here. There we go. So we got molten iron dripping down into that tray of sand. The reaction is kind of slowing down. This went really well. It's not being too crazy. Once it's safe, and you can see, we even, as you said, Dan, we broke the clay pot.
There's a little bit of a crack there, yeah.
A little bit of crackling there. But I think if I can just get in here quickly, we can pull out the slab of molten iron. There's some sand that's been melted into that as well. So this is what the thermite reaction was actually sort of not created for, but when it was discovered, they used this molten iron to weld train tracks together.
Oh, yeah.
So you'd wrap a crucible like this around the train tracks, and instead of bolting them together, and you bolt them together, it's going to wear down. But this made a smooth track. And today it's still used for that purpose.
So how hot would this be then? That'd be that 2,000, probably cooling down from here.
It's rapidly cooling down. When it was first formed, it was around 1,500 degrees.
Right.
Right. I mean, the reaction could get even higher. But let's see if I can drop this one down there. We got, it's melted my tongs together.
Oh dear.
I'm stuck. But we do have another little glob down here in the sand of really hot iron. I don't know if the camera can see that, but it's similar to this. So, thermite reaction.
That is so cool. Yeah, you can see it kind of glowing and just kind of coming in from the edges here as it's slowly cooling. Of course, you have that more molten core, I guess. But boy, that really did destroy the...
A nice coating of melted sand on the surface there as well. So, yeah.
Fantastic stuff. All right, do not try that at home. That is one of several. You probably shouldn't try it at home here, but
don't do that, no.
Very cool stuff, though. I'm Dan. That's Carl. That is how you imagine it.